Hello guys and welcome to the presentation of quad tree. So what is a quad tree? Yeah, it actually looks scary, but it's not. So let's fight this quad tree by narrowing it down. So you always fear what you don't understand. So let's tackle it down. What is a quad tree? So basically it's a node connecting to 4 different nodes. As you can see, it's simple. Okay, so why should we use it? Uh, when you actually search for a point and you want to know the distance of all points beside it, what you're going to do is gonna search in square time. So let's see, you're gonna do that, and that's in square time if you're going to do it for all of them. Yeah, that is actually in square. So uh, let's take for instance 10, and the n square of 10 is 100. But what about quad tree? What is the big O notation of quad tree? So let's look at more examples. 100 is 10,000, 1,000 is a million, and 10,000 is 100 million. That's crazy. So let's look at quad tree. N times log n of n big notation. So 100 or a 10 is actually gonna take us 10, and 100 is gonna take us 200. 1,000, 3,000, 10,000, 40,000. We narrowed down from 100 million to a 40,000 searches. That's already crazy. Back to our subject. So what is our code is doing here? It's just making a quad tree basically and making it better for visualization. And this is what it looks like at the end. So there's two parts of the code. One is the highlighter, and the second part is the searching the quad tree, and that's it. That's what you really actually need to know here. So what we have here is a highlighter, that's what I said, and the second part of the code is the one that's doing this, the quad tree, and that's it. Thank you for listening. Hope you enjoyed the lecture.
Hello everyone, my name is Ayman and today I will be talking about collision detection. First thing you need is D3.force collide, which will do most of the job for you by centering the X and Y axis, and then collision, where you will have to add something which I will talk about later, and by doing that it will make the collision happen, and then it links also the nodes together. And body is like the strength of the it's like the force, how will it collide and where it will go. And then there is the positioning, which is the radius, and then you will have to set the height, which will be around 955, and the width you don't have to really set it up since they didn't do. And then there is the pointer, which I said I will explain. It will be the thing that will help you make the collision happen, since you don't have any real thing like throwing another ball, so you will just move the pointer and it will make the collision happen. And this is the code for it, and that's it. Thank you for listening.
Hello everyone, I will present about collagen detection. This example uses collagen force, which treats knots as circle with a given radius. So the idea is, if the distance between two centers is greater than the sum of the two radiuses, there will be no overlapping, while if the distance is less than the total of the two radiuses, there will be overlapping. So first we will create an array list. Then we will use for simulation, which control the strength of the collision. So if it's very high, the collision will be very slow, and if it's less, it will be very fast. Then we will do the calculation part, and this is the result. Thank you for listening.
Hi everyone, my name is Raya and I'm gonna present to you about the polygon clipping. So basically the Sutherland algorithm is used to display the clipping polygons. So let's start with this collection of polygons which represents the clip polygon, the subject polygon and the intersection between them which is the clipped polygon. So, given a sequence of points of the clip and the subject polygons, the clip polygon function returns the intersection of 2 points. If they don't intersect, then it will returns null. Moving to the second function, which is the line orient function. So the parameters here needed a point and a line, and it will return true if the point is on a side of the line, and false if it intersects or on the other side of the line. This function returns the point at which two lines intersect, assuming that the lines are not in parallel. The polygon closed function returns true if the provided sequence of points represents a closed polygon. Finally, the polygon convex function returns true if the given points represent a convex polygon, assuming that there are 3 points or more, and in counterclockwise order. All the information and the presented algorithm was from this website. You can check it out later. If there's any question, please feel free to ask. Thank you.
Hello everybody, my name is Nora Laghfali and today I will talk about force-directed lattice. First of all, here is a video of how it works. This demonstrates force link iterations, which strengthens D3 force link constraint by applying the constraint multiple times per simulation step. And in this visualization, they use something they call it D3 force. This modula implements a velocity varlet numerical integrator for simulating a physical forces on partials. And in the domain of information visualization, physical simulation are useful for studying networks and hierarchies. To use this modula, the force-directed lattice, first of all, we create a simulation for an array of nodes and compose the desired forces. Then they listen for the tick events to render the nodes as they update in your preferred graphic system, like Canvas or something they call it SVG. And in the code, we can notice the function of the tick where they can listen for it, and then they can move it. And that's it. Thank you so much for your listening.
Visibility chart, which is mainly a chart that represents a globe with data points that are related to geographical areas. This chart was created using D3 JavaScript library, which is used to create a dynamic interactive online data visualization. So as any other library, this library has several functions such as zooming in and out. But the main function is geographies that is used to project the map on the sphere and to locate those data points. So each point in here represents an airport in this example. So we are using airports.csv for the data, using longitude and latitude to plot them. And as I said, it is actually land, which is a map, and points that are projected to a sphere. We can see it in here for the projection, and then it was rendered. So this type of chart is useful because there are a lot of data that are related to locations. So this helps us to visualize them, and this type of chart does not need any labels. So we can cluster these data points based on countries or continents